Alright, ladies and gentlemen, today we're going to be talking about some basic operations with our complex functions. I'm sorry, not complex function, but complex numbers. Complex numbers are going to be treated very, very similarly to any other type of math problem that we've done where we have to distribute things and combine like terms. You've seen similar problems like this in the complex conjugates video. So the skills that we saw there are going to be pretty much the same skills that we see here. What they're talking about here in step number 1 is basically do your order of operations. Simplify everything inside the parentheses that you can, and then start distributing and combining any like terms. So make sure you get this copied down into your notes, and let's look at our first example here. Now, this is a really good example because it gives us a couple of terms, the square root of 20 and the square root of negative 12, that tell us we need to simplify those first inside of the parentheses before we distribute and combine like terms. So let's take a look at the square root of 20. In previous lessons, you've seen how to simplify a radical number. So just as a quick offside here, we'll say the square root of 20. Well, that is the same thing as saying 4 times 5, and 4 is a perfect square, so that gives us 2 square root of 5 as a remainder. So what we're going to do is inside of the parentheses, we're going to simplify it. So square root of 20 becomes 2 square root of 5. The square root of 3, negative, while it doesn't have any perfect square factors, it does have a negative 1 that can be taken out. So that would give me I square root of 3. And in the second set of parentheses, the square root of 5 doesn't simplify at all, but the square root of 12 would simplify to be 2I radical 3. Because just in case everybody needs to see it, for this particular example, the square root of negative 12 is 4 times 3 times negative 1. The 4 produces the whole number 2, the negative 1 gives you the I, and the radical 3 doesn't simplify, so it stays that way. So we've simplified what we can inside of the parentheses. Now you see separating the parentheses is a subtraction operation. That tells you that you're going to distribute a negative 1 into the parentheses. So since on the left parenthesis there's really nothing there except a positive 1, and that doesn't change anything, we can rewrite the left side without the parentheses. So 2 radical 5, 2 radical 5 minus radical, or I radical 3. Here, when we distribute, the negative times the positive radical 5 will give me a negative radical 5. Negative times the negative 2I will give me a positive 2I radical 3. Now, one thing before I continue, I just want to point out back in this row, once we simplified things, notice that everything that we simplified gave us radicals that have the same parts. So the square root of 20 simplified to be radical 5, which matches the radical 5 that was given to us on the other side. Same thing here. On the left side, we were given something with a radical 3, but on the right side, when we simplified it, we got something that gave us a radical 3. So that is allowing us to identify that we have some like terms that we can combine. And most of the problems that you'll see are designed to do just that. So if you simplify your problem and it does not give you the same radical parts, double check your work because you might have made a mistake there. I'm not saying that it'll always be that way, but most of the time the radical parts should be the same. Because what we see here is we have a real number, 2 radical 5, and another real number, negative radical 5. So that's like saying 2 minus 1, which would give you 1 radical 5 left over. Now the imaginary parts, I have a negative I radical 3 and a positive 2I radical 3, and those are like terms as well because they have the same radical part. So when you add those together there, that's going to give you uh, just a single I positive radical 3. And sorry if it sounds like I'm looking, if I'm pausing here for a second, because I looked at my notes and I think I made a mistake on my notes, but the problem itself looks fine. So let's go ahead and move on. This is the correct simplified answer in A plus BI form, where if you were asked to identify it, A would be the square root of 5 and B would be the square root of 3. So let's take a look at this next example here. Moving on. Now this one, that first step at the very beginning of the presentation doesn't really apply because inside of each set of parentheses, there is nothing to simplify. The 3.1i, the 2.5, the 4.3, the 2.4i, there's nothing that we can simplify. Nothing was given to us in radical form, and because they're complex numbers, we cannot combine the real and the imaginary parts. So all we have to do at this point, because we have a plus operation in between the parentheses, we can just drop the parentheses and start combining our like terms. So 2.5 minus 3.1i plus the 4.3 plus 2.4i, and simply identify the like terms and combine them. Sometimes I like to do this just to demonstrate what the like terms are without having to rewrite the entire problem with the like terms next to each other. So 2.5 plus 4.3, that's going to give you 6.8. And the negative 3.1 plus the positive 2.4i, that's going to give you a negative 0.7i. And there you go. That's the final simplified answer on that one. Relatively easy. No simplification uh, with radicals required on that one. Excuse me. Now here, again, I can hear, even though I'm not with you, some of us taking a deep breath. We see those dreaded fractions again. Again, for an example like this, some of us are going to be tempted to try and get rid of the fractions completely with a lowest common denominator for the entire thing. Now, unfortunately, this cannot work, just like what we saw with the complex conjugates example previously. Because this is an expression and not an equation where I have something that is balanced, we cannot really get rid of all of the fractions completely by multiplying everything through with a common denominator, or our lowest common term. So unfortunately, we're not going to be able to do that right now. So let's go ahead and rewrite the problem. Since we have a plus operation inside of the, in between the two parentheses, we're just distributing positive ones everywhere, and positive one never changes anything. So we're going to just rewrite the problem minus the parentheses. Now I will take one extra step in working this example out. I'm going to go ahead and combine my real terms, the negative 4 and the positive 13, to give me a 9. And I'm simply going to rewrite the other two terms together so it's a little easier to see how we're going to get a common denominator between them, because this is just a very old school kind of addition with fractions where we just have to identify a common denominator between these two terms. So between the 6 and the 8, the lowest common denominator between those is going to be a 4. So I'm going to take this 5 over 6 term and I'm going to multiply, I'm sorry, I said 4, I meant to say 24. I'm going to take this and I'm going to multiply a 4 to the top and the bottom. And so that would give me 9 here. And if I multiply that, that's going to give me a negative 20 over 24i. And looking at this one, I'm going to multiply a 3 to the top and the bottom to get a common denominator here, and that will give me 9 over 24i. I. And now that we have a common denominator with the two imaginary parts, we can go ahead and combine those together. And the negative 20 with the positive 9, remember when we add fractions together, we just add the numerator, and that would give me a negative 11 over 24i. And that would be the final simplified form of that one. Sorry, can't get rid of all the fractions with the common denominator for the whole thing because they wouldn't be proportional. So here, again, they're just kind of giving you a brief reminder. I is the same thing as the square root of negative 1. I squared is equal to negative 1. So basically anything that says I squared, we're going to just go ahead and be able to substitute a negative 1 with that. Now these examples that you're going to see, they're very indicative, very similar to the complex conjugate problems that you saw in the previous lesson. The difference is because we're not actually doing operations with conjugates, there's no particular special rule that we have to use. Like, you know, when we multiplied conjugate pairs together, we could just simplify it and just say a squared plus b squared. In this case, because we're not doing conjugate pairs, we just have to use our FOIL method or distribution method and combine like terms like we would normally do if they were regular variables that we're working with. So here in example A, we're going to take the negative 7 and simply distribute it to the values inside of the parentheses. So this would produce a negative 21 minus 35i, and that's all she said for that one. That one's done. This one here, again, because they're not conjugate pairs, for example B, we have no choice but to fall back to our FOIL methods. So negative 4 times a positive 3 will give me negative 12. The outer terms, negative 4 and the positive 2, will give me negative 8i. The inner terms, negative 2 and the 3, will give me a negative 6i. And the last terms, negative 2 and the positive 2, will give me negative 4i squared. We can't forget the i's are being multiplied as well. So we have our like terms are always going to be the 2 in the middle with our FOIL process, and that'll give me a negative 12 and minus 14i. And of course, anywhere we have I squared, we can replace that with a negative 1. And that'll give us two more like terms that we can combine. Negative 12 minus 14i. The negative 4 times the negative 1 gives me a positive 4. And of course, the 4 and the 12, those are both real numbers. They're like terms. Those combine. So my final simplified form here is negative 8 minus 14i. And one final example here. Again, simple FOIL multiplication, combine your like terms, but again, without obviously conjugate pairs like we saw in the previous lesson. So first terms, 5 times 7 gives you negative 35. The outer terms will give you a positive 15i. Inner terms are going to give you negative 14i, and the last terms together will give you a positive 6i squared. The middle terms are like, so let's go ahead and combine those. Negative 35 plus 1i is what's going to be left, plus 6, and replace the I squared with negative 1. So that would simplify to be 35 plus I. Positive 6 times negative 1 will give me a negative 6. And finally, the like terms, negative 35 and 6, gives you negative 41 plus I. And that would be the final simplified form of that. So again, if you paid attention to how we simplified radical numbers a couple lessons ago and how we multiplied and combined like terms with conjugate pairs in the previous lesson, then this particular set of operations that we're looking at really shouldn't pose much of a challenge for you. But as always, if you have questions, please make sure you come see me, and look forward to seeing you guys in class.